For decades, we were told that humanoid robots were a distant dream, a curiosity for the laboratory. But in the last 24 months, that dream hasn't just woken up, it's started running. The speed of advancement is defying every projection, every expert forecast, and every expectation. From the factory floors of Texas to the research labs of Sunnyvale, a new workforce is being born. And they are taking over faster than anyone expected. Welcome to the Future Vault. I'm your host, and today we are witnessing the most significant shift in labor since the Industrial Revolution. We aren't just talking about specialized machines. We're talking about general-purpose humanoids designed to live and work in our world. In this documentary, we explore the players, the breakthroughs, and the inevitable impact on our jobs and our future. Why is this happening now? To understand the present, we have to look at the convergence of three massive breakthroughs. First, hardware. We've finally solved the problem of power density. Modern electric actuators are now stronger and lighter than human muscle. Combined with new battery tech, these machines can finally operate for a full shift without being tethered to a wall. Second, compute. The chips driving these robots are now capable of processing trillions of operations per second locally. This allows for real-time spatial awareness that was impossible just 5 years ago. They don't just see, they understand. But the real secret sauce is the shift from coding to learning. We are no longer telling robots exactly where to move. We are giving them neural networks and letting them learn by watching us. This is the foundation model moment for robotics, and no company has brought this to the public consciousness quite like Tesla. Let's talk about Optimus. Tesla's Optimus, or Bumblebee, started as a man in a suit. But today, it's a sophisticated machine integrated into one of the world's most advanced AI stacks. Elon Musk's vision is simple: a humanoid that costs less than a car and can do almost anything. And he's already putting them to work. Tesla's advantage isn't just AI, it's manufacturing scale. If anyone can build millions of humanoids, it's the company that redefined the electric car. Musk believes that the Optimus program will eventually be worth more than Tesla's automotive and energy businesses combined. A bold claim that is starting to look plausible. But Tesla isn't alone. In the heart of Silicon Valley, a startup called Figure AI is moving even faster. Figure AI made waves when they showed their robot, Figure 01, having a conversation while performing tasks. This wasn't a script, it was reasoning. By partnering with OpenAI, Figure is giving their hardware a brain that can speak, see, and plan its own actions. And they aren't just for show. Figure has already signed deals to deploy these robots into BMW plants, marking the start of a new industrial era. The goal is to prove that humanoids can handle the brownfield environments, the factories designed for humans, not just custom-built robotic lines. While Tesla and Figure dominate the headlines, the veterans of the industry are evolving just as quickly. Boston Dynamics shocked the world by retiring their hydraulic Atlas and replacing it with a fully electric version. It's stronger, slimmer, and more agile. Atlas has always been the gold standard for movement. Now, it's being groomed for the commercial market, backed by Hyundai's massive resources. Then there's Agility Robotics. Their robot, Digit, was the first to get a real job, working in Amazon's fulfillment centers. Agility is opening RoboFab, the world's first factory capable of producing 10,000 humanoid robots a year. The scale is becoming real. From China, Unitree is pushing the limits of speed and cost. Their H1 robot is already one of the fastest humanoids ever built. They are aiming for a price point that could bring humanoids not just to factories, but eventually to every home. Cost is the final barrier. But this isn't just a US versus China race, it's a global competition for technological supremacy. Let's look at the other contenders. Sanctuary AI, based in Canada, is building Phoenix. Their focus is on human-like intelligence for a wide range of tasks, driven by their Carbon AI system. They believe that by capturing human demonstrations, they can train their robots to handle the unpredictability of the real world. In Austin, Apptronik is developing Apollo. Backed by NASA heritage, Apollo is designed to be the iPhone of robots, a platform for apps. Apptronik is focusing on ease of use and safety, ensuring their robots can work alongside humans without cages or barriers. And connecting them all is NVIDIA. Their Project GROOT is a foundation model designed specifically for humanoid robots, providing a shared intelligence. NVIDIA isn't just building chips, they are building the operating system for the entire industry, accelerating development for everyone. Hardware is impressive, but it's the brain that is the real game changer. Let's look at the AI breakthroughs driving this revolution. We used to have to program every single movement. Now, large language models are allowing robots to understand natural language commands. Instead of move joint X by 10 degrees, we can say, pick up that cup. And the robot figures out the rest using spatial reasoning. Simulation is the other half of the puzzle. Companies like NVIDIA are creating digital twins where robots can practice for millions of hours in seconds. What they learn in the virtual world transfers perfectly to the physical one. This sim-to-real pipeline is why they are learning so fast. Vision transformers are allowing these machines to see the world like we do, identifying objects, predicting their weight, and understanding how to grip them. This common sense for the physical world is the breakthrough that has eluded us for 60 years. Now it's finally here. But as these machines enter our world, they bring a host of complex ethical and social questions. We need to talk about the impact. Will we trust these machines in our homes? With our children? With our elderly? Safety and reliability are paramount. One mistake could set the entire industry back by years. The pressure to get it right is immense, but so is the pressure to move fast. Then there's privacy. A humanoid robot is a walking camera and sensor array. Where does that data go and who owns it? As these machines become more integrated into our private lives, the security of their brains will become a matter of national importance. Governments are already scrambling to catch up. How do we regulate a machine that can perform almost any human task? Establishing global standards for safety, ethics, and employment will be the defining challenge of the next decade. But with this speed comes a massive economic question. How will this change the way we work and live? Much of the developed world is facing a demographic crisis. A shrinking workforce means fewer people to build, move, and care for us. Humanoids offer a solution. They don't get tired, they don't need breaks, and they can work in environments too dangerous for humans. However, the fear of displacement is real. Millions of roles in logistics, manufacturing, and even service could be automated within a decade. Optimists argue that this will free humans from mundane labor, allowing us to focus on higher-level creativity and management. The reality will likely be somewhere in between. Some see a path to a post-scarcity world, where the cost of goods and services collapses because labor is essentially free. This could be the greatest increase in human wealth in history, or the greatest increase in inequality. The choice is ours. So, where do we go from here? If we look at the next 5 years, the changes will be localized but profound. By 2030, humanoid robots will likely be the standard in structured environments like logistics centers and automotive assembly lines. They will move from experimental to essential, becoming a common capital expense for any major corporation. Reliability will be proven. We'll see them in retail backrooms, handling inventory, and in hospital corridors, moving supplies and equipment. The invisible labor will be theirs. We are not just building machines, we are building a new chapter in the human story. A story where our machines are our partners. But 10 years from now, that's where the world starts to look like a science fiction movie. The home is the final frontier. By 2035, the cost of humanoid robots could drop to the level of a high-end appliance. We could see them entering the domestic sphere. This will redefine urban living, elder care, and the very nature of human labor. We are entering the age of the general-purpose machine. A personal robot could be as common as a dishwasher today, handling chores, maintenance, and even companionship. A helper for every home. Simulation is the other half of the puzzle. Companies like NVIDIA are creating digital twins where robots can practice for millions of hours in seconds. Thanks for watching. We'll see you in the future. Check out these other deep dives from the Future Vault Media. Stay curious, stay informed. The Future Vault. Credits rolling over a dark tech background. Don't miss our next episode on the future of AGI. Hit the bell to stay updated. The future is unfolding fast. Don't get left behind. If you found this deep dive valuable, hit the subscribe button and join us at the Future Vault Media. Your support helps us explore the frontiers of technology.